Hey all, welcome to the 10th episode of Distributed Systems 101 series. So in the previous couple of episodes we have talked a lot about database sharding on the basis of primary indexes, and in this one we will be talking about database sharding as well, but in this one we will talking about how we shard the data items within the database on the basis of their secondary keys or secondary indexes. So what we are doing is that we're gonna discuss sharding or basically partitioning, right, by secondary index. So this is the theme of this current episode. So in the previous episode we have talked a lot about primary indexes, so if you haven't watched that, do give it a watch. That can be a good prerequisite for this particular episode. And let's begin, let's start. So what are secondary indexes, right? So you all must have heard about primary indexes, right? So, or primary keys as well. So primary index or primary key are basically are those fields of a particular table which define every data item uniquely, right? That is the concept behind the primary indexes. But secondary indexes is not like that. Secondary indexes does not guarantee uniqueness, right? So we can say that there is no uniqueness guarantee that comes with the secondary indexes, but that they can be very helpful if you want to search a data item with the different type of fields or values, right? So in those cases you can make them secondary indexes and can perform queries on top of it, and that can be really fast because we are applying indexes there. So this is the concept here. What we'll do is that we will gonna shard the database or the data items with the help of these secondary indexes or the secondary keys. Basically what we'll try to do is that we'll perform sharding on the secondary indexes. So we are basically looking two ways in which we will try to shard this. So let's write it down here. So sharding by secondary indexes. So we'll be looking two ways. So first we will be looking is the document based partitioning, and the second we'll be looking into term based partitioning. So these are the two things basically which we'll be looking into, right? And in both of them we will gonna cover local secondary indexes, and in this one we're gonna cover global secondary indexes, right? Which you must have, if you have worked with a NoSQL databases, you must be knowing them, or with Amazon DynamoDB you must have known them with the acronym of LSIs and GSIs, right? So this is the agenda here. Apart from that, we will gonna use the example which we used in the previous episode as well of the database sharding. So what the example is, if you haven't watched the previous episode, do give it a watch, but still I'm gonna just describe the example here. So the case which we were describing in the previous episode was that there were a lot of students which were trying to register themselves for a CS course, right? So this was the example. So a lot of students were there who were trying to register themselves for the CS course, but the catch here is that we have all the registrations were stored in the shards of the databases. Now earlier what we have is that we had primary keys. So for the in one of the example for the primary keys, we took name of the student as the primary key, while on the other hand, on the second example of the previous episode, we took the date, right? Basically the date of registration as a primary key, right? Now in this example we will also take secondary keys. Now we will have two secondary keys here. One would be the graduation year, right? So it basically will depict in which year the student will gonna graduate, and the second secondary key, so I'll gonna make it sk1 and sk2, and the second graduation year will be the course. So it basically tells what course in the CS course, or basically what particular course for which the students have registered themselves into, right? So these are the two secondary keys, or the secondary indexes, which we'll be looking into this episode while we walk through the document based and the term based sharding. Now let's discuss about the first type, which is called document based sharding, or we can also call it sharding by document. I'm gonna move it here. Okay. So we also call this sharding by document. Now we'll discuss this first. So what is sharding by document? So here the concept is that like whatever like secondary index we are sharding it with will be like every database, or every database instance will have their own copy of secondary indexes, and hence we call it a local secondary indexes. So every database shard will maintain their own copy of their local secondary indexes, right, or secondary indexes. So in previous example we discussed, we have a like we had a student student basically a table, or like a database of a student who were registering themselves into the CS course, right? So this was the thing which we discussed previously in our previous example. Now we will look at particularly into this student database. So for the student database we have primary key as the name, right? Along with that we have secondary keys. So the first secondary key is the graduation year, right? We can also call it a grad year, and second secondary index is the course, so the course for which they register into. Apart from that, there can be some more metadata as well, or you can also consider that as some more fields. It can be age, right? It can be a gender, it can be phone number, address, and a lot of things which can relate to a student table, right? So basically we'll be focusing on these two secondary keys, and we'll see how we can shard this under the document based sharding. So what we'll do is that we're gonna see how a particular database instance will have this particular shard, right? So let me draw it up here. So let's for example, let's see, we have this big box here. Okay, pretty big box because we have to cover a lot of things. What I'll do is that I will divide it into two parts. Okay, I'm not sure will I be able to cover the contents here, but let's at least start. So what I'll do is that like above we'll have the detail of the, like suppose this is a shard, right? Let's call it shard1, right, or a DB instance, right? So this particular DB instance will hold some data. Now what data will it hold? Suppose it, so obviously it will hold the details of student, right? So we will describe a couple of student rows which are stored here in this instance, and then we will see how their secondary keys are stored here in this DB instance. So let's define 4 of the student entries here. So what I'm gonna do is that I'm gonna just define the entry. So let's say here we have a primary key. Okay, so let's first define, we have a student name called Alex, right? So along with Alex, this is the primary key, but along with this primary key there will be other fields as well basically. So obviously we will have one of the primary key, that is a course. So let's see it registered into the OS course or operating system course, right? Now we will also have a graduation year, or we will simply call it a grad year basically. And let's see, suppose the graduation year is the first year. Okay, and let's see we have some metadata. So let's see, we have a metadata of age here, which is 18. Got it? Now similarly we have another student called Bob. Okay, so for Bob similarly we will have a course here. Suppose Bob registered into the networks course. Okay, along with that we also have the graduation year of Bob, right, which is, let's call it, he is in a second year. And along with that we also have age. Let's call it the age of Bob is 17. Okay, now we also have another student. Let's call them Branda. Okay, now Branda has their own details. So let's say the course of Branda was again networks, right? The graduation year was obviously, let's say the graduation year was first year, and let's say they have some metadata of age as well, which I will not define because we have less space here. Now we have another student coming up is Clement, and Clement will also have some data, so I'm just gonna define the secondary keys here. So let's see, the course is database, so Clement is signing up for database course and he's in third year. So yep, and they also have some metadata here as well. So the age is there, but I'm not gonna like write it down because we have less space. So yeah, this is the database instance, and this database instance holds details of 4 students, right? Alex, Bob, Branda, and Clement. Along with that, all the students have their secondary keys and other metadata assigned. Okay, now this is the basic entry of the student. Now the interesting part is the secondary key, like how the secondary keys are stored in this instance. So as I discussed that, like the secondary keys which are stored here is the local secondary keys, or basically every database instance store their own copy or maintain their own copy of local secondary or own copy of their secondary indexes, right? So whatever secondary indexes for this instance, this particular instance will hold that. All the secondary index of this particular data item or entry of students, this instance will hold that indexes. So we have like secondary indexes, course and graduation year, right? So we already discussed that. Now let's see how it is stored here. So first let's see, we have a course here. Okay, course OS, so this is one secondary index. Now if we see here, this secondary index operating system, Alex is the only student who has taken up the OS course, so the primary key of that particular student will be stored here. So the essence we discussed that the primary key here for the student instance, so student database is the name, so we are storing the name of the student. Okay, now moving ahead, we have another course, right, which is networks. Now for networks, if we see here, we can see there are 2 students who has registered for networks course, and they are Bob and Branda, right? Now again we have another course which is database, and for this we have one student, Clement, who has registered for database course, right? As we can see above, Clement has registered for a database course. Now moving ahead, so course was one secondary key, another secondary key was graduation year, right? So for the graduation year we have the first year first. So for the first year we have 2 students, basically they are Alex and Branda. They were in their second year. Now again same graduation year but second year. So for graduation year, which is like all the students who are in second year of their graduation, it will be entered here, and we have one entry, that is Bob, right? Now if we have to write the graduation year ahead again, so this time graduation year third. Okay, so for third I'm running out of space here, but let's see. Okay, cool. So I think it is readable. So we have Clement here. Okay, so for graduation year, which is third year, we have Clement here. Now this is the way in which a document based partition instances store their secondary keys. Now every instance will have their own copy. So if we have another database instance like this, right? So suppose we have another database instance which have their own entry of students here, then they will have their corresponding secondary key entries here with their particular primary keys here, right? They have their mappings stored here, and that's why this entire concept is this entire way of storing the secondary index, they are called local secondary index, because all the secondary indexes are stored locally in every database instance. This is basically called document based sharding. Now let's discuss how we can handle reads and writes in a document based sharded instance, right? So I'm gonna like scroll down here. So we discussed in detail what document based sharding is, and we see how particular instances store secondary keys locally. Now let's undraw this. So suppose we have a particular, what we discussed is that we have a particular instance, right? We call it maybe DB instance 1, and what we have is that we divided it into two parts. So first was the entry of the students along with their primary keys, right? So we have the primary keys and we have the rest of the metadata here, and this was like repeated for every student entry, right? So this was the way we did that. So if there are like 100 students, there will be 100 entries here. And now along with this we have the secondary key concept here. So what we did is that whatever secondary key we have, so suppose we have 3 secondary keys, then for every secondary key value, right, we have the corresponding list of primary keys here, right? So for every secondary keys we had the list of primary keys here. So what it does, so if you want to query something through their secondary indexes, you can get a list of primary indexes for those secondary indexes, and then you can refer those primary indexes here and you can get the data out, right? You can get the entire data out for the particular secondary key which you are searching for. So this is the concept of document based sharding. So how to perform writes, right? So when a particular client comes up and say that, hey, I want to write something, so I want to write a student instance here, right? I have a student entry who is trying to register for a CS course and I want to write it into this instance. Now what will happen here? So writing basically writing into the DB instance is not that complex, because it only hampers one of the database instance in which it is being written to. Because why? Because all the secondary key for that particular student will be stored in that database instance only. So suppose if you want to register a particular student here, so suppose if you want to register maybe Matt, yeah, you want to register Matt here, whose maybe whose course was maybe they were picking up for DSA and their graduation year was 3rd. So what will happen is that we will have a Matt entry here. So we will have an additional, suppose we will have an additional Matt entry here, right? A +1 Matt entry with primary key being Matt and the rest of the details here. And very easily for the secondary key we will add the entry of Matt at the particular place. So for the particular secondary key, so if the course where the course was DSA, right, they will have a list of primary keys here. In this list we will simply gonna add Matt as well so that we can refer to it, and same for the second secondary index, and the second secondary index is graduation year, so I'm gonna move it back. Yes, so for the graduation year, which is 3rd year, we will also again have a list of entries, and in this list of entry we will gonna add Matt here so that they can be referred. So you understand, right? If when we are adding an extra entry of Matt, we are only and only modifying one DB instance, right? We are only modifying 1 dB instance, and hence the write process is easy, or a write process is not that complex. It does not involve many instances, but the read process here is a bit complex, and we're gonna cover that up next. Now let's discuss the read process. So we discussed the write process, and it was simple because it was only affecting one of the database instance. We only need to modify one database instance in order to add our student entry. But what happens if we read through a secondary indexes? So the whole concept is of this lecture is to shard through the secondary indexes. So let's read through the sharded index. So suppose if a client says that, okay, you have like sharded your database on the basis of the secondary key, and those keys were courses and graduation year. So can you like tell me or can you give me a list of students whose course was basically networks, right? So give me a list of all the students who registered into the networks course. Now this particular query will affect more than one database instance, or it will gonna like have to go through all the database instance present in the DB in order to get the result. Why is that? Because we are like here we are having the concept of local secondary indexes, and the fact that every database instance is maintaining their own set of secondary indexes, and that is the reason that we have to check for every database instance that, hey, do you have the particular index whose value is network, or basically do you have a particular secondary index course which is basically networks. So can you give me a list of all the students who have the secondary key as course as networks, right? We have to do that. So for example, one part of the query has to go and read this particular DB instance, and what they will do is that when they will read, they will ask here in this secondary keys, in this maintained LSIs, they will ask for the course networks, and they will get a list of primary keys, or the list of student entries of primary keys who are registered into the networks course, and that is basically Bob and Branda. So for Bob and Branda, they will gonna go here and get into the fetch the entire details. So this will give them the result, and from this instance they will have two result, right? They have Bob along with the rest of their metadata, and they have Branda along with that they have the rest of the metadata. So this was first result set, or we can call it RS1. Now this is the first result set. This we have to do this for all the instances in order to get the result, right? So if we have to like generalize this, we can look at here again. So if we have to generalize this for the course networks, suppose we have like maybe 3 to 4, suppose we have 3 instances, right? The instances we discussed previously. Similarly, we have 3 instances. Let's call it DB instance 1, DB instance 2, and DB instance 3. And similarly, they have divided into 2 parts, where first one will have primary key along with their metadatas, right? And then we will have secondary key along with the list of the primary keys, and same thing here as well, right? So these are the 3 instances, 3 similar instances having similar structure. Now for the course networks, what we have to do now here is that we have to, in order to read or in order to get the entire result, we have to query every instance, right? The same way we did earlier, we have to query every instance for the course network, and all the instance will give their own response that, hey, for me these are the student list who are registered into the networks course. Now they will have their own responses, right? So they will there have their own responses. Let's call them RS1, very similar to this particular response which we have here, right? Very similar to this one. Okay, now Moving ahead, we have response 1. Similarly, we have response 2 and we have response 3. Now again what we have to do is that we have to further join back all these 3 responses. We join back the response and we make a full list of response here. Now this is the entire list of response and this should be returned back to the client. Like this is the final list of the response which should be returned back to the client in order to like basically understand that what is going on here. So I'm gonna zoom out a little bit so that we can get the full picture here, right? So we have 2 instances here, or sorry, 3 instances here, right? All of them received the query, returned their own copy of or own set of responses. We joined them back, made the full copy of response here, and then returned it to the client here. Right? This is the entire structure, and this entire structure which we are seeing is called scatter gather approach. And why it is called scatter gather approach? Because all the responses were scattered into their own instances and we gathered them here, right? We basically joined them or gathered those scattered responses here to make the full list of response, and then we returned back to the client. And that is the whole, this is the entire way in which a client can perform a read on a document based sharded database.